Yeah, we're looking at high throughput manufacturing of nuclear reactors, which I don't think anybody strung all those words together and made it real.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America.
that is willing to
But we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new fuels.
and focus on net public
We need
benefit
engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those technologies.
then we will march towards this.
We need workers to operate assembly lines that hum with high-tech, zero-carbon
We have
components.
unlimited prosperity for all human.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Hello, everyone. Welcome back. We are super excited today. We've got an awesome guest. We're very happy to have him on the call today. So his name is Joe Miller. He's the president of advanced technologies with BWXT. Joe, how you doing?
I'm doing great. Yeah. Thank you, Mark. Thank you for having me on the podcast.
Absolutely. Yeah, we've got a lot to cover today, so we'll try and jump right in. BWXT, Project PELE, kind of the broader energy industry. But before we get all to that, I'd love to kind of cover just you and your background, where you come from, and how you got into the industry.
Excellent. Yeah. So out of high school, I joined the Navy. And when I was in the Navy, I enlisted as a nuclear machinist mate. So went through boot camp in Illinois, went through some power school classes in Orlando, Florida, then spent some time in Charleston, and then finished the Navy nuclear pipeline up in New York, qualifying as a machinist mate and engineering laboratory technician. So essentially, I didn't know much about nuclear when I was 18, joined the Navy, was exposed to the engineering and the science and the operations behind nuclear, and became fascinated with it right off the bat, and really started to enjoy what it takes to operate a nuclear power plant, and also understand the cause and effect relationship of an engine room of a nuclear system, and all the physics and design parameters that go along with that. So while I was deployed on a fast attack submarine, the USS Norfolk. Really enjoyed my time going to sea and just being part of that important mission. And as I was getting close to concluding my 6-year enlistment, I decided to get back into school, and I got my bachelor's degree in nuclear engineering technology. And from there, I was honorably discharged in late 2003, early 2004. I started working at the shipyard in Newport News, Virginia, building new construction submarines, the Virginia-class submarines, which was pretty interesting for me. And the theme of my career has been starting from operations, really the end point of a system, and understanding how they operate and understanding all of the complexities and interfaces that are required to create nuclear propulsion and nuclear power. And then I've worked my way almost backwards from the shipyard through some high-tech industry experience that I had in semiconductor manufacturing. And then here at BWXT, understanding more about the thermal hydraulic tests that are required to be able to qualify nuclear systems, and then back into research and development. And as advanced technologies grows in my business unit, what I've been able to learn is being able to use that operational experience that I have has been instrumental when you couple that with research and development and product development to be able to get back into prototyping, and then eventually going full circle into production and manufacturing and ultimately operations.
No, that's awesome. That's incredible. I think starting at the end use and starting with the customer in mind is always helpful, and having folks that have actually been present and been hands-on and seen kind of the whole process from start to finish, is invaluable experience. So
absolutely agree.
Yeah, looks like you got a master's in radiation health physics also. I mean, talk to me a little bit about that. What was the motivation behind that?
So when I was working in semiconductor manufacturing, I decided, I had two choices at the time. look at different master's degree programs in business or focus more technical. Just based on what I really enjoy, I was able to find a program that was highly technical, was offering some distance learning. This was in the early days, especially in technical distance learning. So I found the program at Oregon State. I was able to interface with a few of the professors there before I joined that program, and really thought it was well constructed. So being able to couple that with what I wanted to do in my career moving forward, I thought was a good step, and really enjoyed my time at Oregon State.
Awesome. So Joe, talk to us about BWXT. I mean, high level, kind of what do you guys do? How many different business lines do you have besides the company? I'm sure many people listening to this are familiar with nuclear and BWXT as a company, but some people may not be. So give us kind of a high level overview.
Absolutely. So BWXT has two major segments. We have our commercial operations, which is headquartered out of Cambridge, Ontario, and we have government operations, which is headquartered here in Lynchburg, Virginia. So in total, we have roughly about 6,700 employees, so nearly 7,000 employees in North America. We also have operations in the UK and operations in Los Angeles and operations really throughout the United States for different management and operating contracts that we have through our government ops group. So BWXT, our focus is on the naval reactors program. So manufacturing naval fuel for those reactors for both submarines and aircraft carriers. In addition to that, we manufacture specialty nuclear fuel for research and test reactors. And then we have a lot of environmental cleanup and management and operating contracts in the US. On the Canadian business, it's mostly commercial nuclear work for the CANDU reactors, and then also producing large components for a variety of different reactor types, both for pressurized water reactors and boiling water reactors. Also in Canada, we have a strong focus on ramping up our efforts along with small modular reactor vendors to be able to provide them the components they need to launch those different products into the marketplace. And then in Canada, we also have BWXT Medical that focuses on radioisotopes for the medical industry. So cancer fighting drugs and detection and therapeutics and diagnostics is the range of products that we are producing today and also ramping up in commercialization.
Nice. So some of your primary customers might be governments, utilities, research institutes. I mean, you guys cover the kind of the whole gambit of the industry.
That's right. And advanced technologies, we focus on everything that's new and different in nuclear. And primarily our customers are NASA, the Department of Defense, and also the Department of Energy. So we take each one of our designs through the development process with a focus on getting into prototyping and eventually producing each one of these units. At the heart of BWXT, we're a manufacturing company. So our goal is always to manufacture the highest quality products we can for our customers and meet those delivery timelines that they require.
Got it. Makes sense. How's your team thinking about TRISO fuel? Are you guys dabbling in that?
Absolutely. So we've been manufacturing TRISO fuel for over 15 years. And when the national lab system, both at Idaho and Oak Ridge, were ramping up their laboratory scale capabilities in TRISO fuel over almost 2 decades ago, BWXT was there to help with the industrial scale up of that application. So being able to manufacture TRISO fuel was developed by the Department of Energy at the labs, and we worked in collaboration with them to scale that up to an industrial scale. And so we have a TRISO manufacturing facility that can produce the type of quantities that are required for the Strategic Capabilities Office PELE program. And then we also have the ability to ramp up that production as the market requires in the future. So yeah, TRISO is very important to us. And it's not just TRISO for BWXT. We also historically and currently make a variety of different coated fuels, both for my advanced technologies, advanced reactor demonstration program through the Department of Energy. And then we've also been coating different fuel forms for NASA nuclear thermal propulsion, all with that TRISO fuel factory.
Yeah. Do you see anything that distinguishes BWXT's TRISO program from like X Energies or SNCs? I mean, I know you may not be super familiar with them, but just curious, there's a lot of people that are working on kind of vertically integrating the supply chain.
Right. No, it's a great question. I would say the biggest distinction is the fact that we make the fuel today and we can make it in large quantities. So
Yeah.
manufacturing the fuel is a bit of a science, and it's also a bit of an art, a lot of technical know-how that's required, a lot of background and staff. The staff that we have that have been manufacturing this fuel for several years have been able to apply that resource to making TRISO fuel. But in addition to that, the Nuclear Regulatory Commission license that are required, and all of the accountability, material accountability, criticality, safety, the infrastructure, the security, everything that's required to manufacture high-assay LEU fuel, especially TRISO, requires a very complex set of infrastructure and resources. And that's where we have that distinction right now in the marketplace. We can produce the fuel now, we can produce it in large quantities at an industrial scale.
So if there's a microreactor developer or SMR developer that wants to use your guys' fuel as a staple to their business, you think if they place an order far enough in advance that you guys be able to service that request?
Without a doubt. And that's a lot of the conversations that we're having in the marketplace. We feel like the asset that we have in manufacturing TRISO fuel is open for the entire marketplace. And so we've had multiple conversations over the last several years on how we can use that asset to help kickstart some of the TRISO needs and other coated fuel needs and a variety of other fuel needs within the country.
No, I think that's super helpful from kind of an industry-wide perspective, because it's often touted as like there's no TRISO supply chain yet. And the fact that you guys have capability, it's presumably licensed or will be capable of being licensed through the NRC. Yeah, it's a tremendous service to the whole industry.
No, I totally agree, Mark. And I would also say that from a BWXT standpoint, we're just hyper focused on delivery of fuel, delivery of reactors. We've been doing it for 6 decades plus, and in doing so, when that market is real, when those orders are placed, we have the infrastructure and we have the ability to ramp for whatever's required.
Yeah. Well, we had listed on our kind of list of questions, is there anything in nuclear that BWXT doesn't do? I'm inclined to say no after your brief description, but I'll ask that question anyway. Is there anything you guys don't do?
Well, there's some parts of the fuel cycle that we're not focusing on. So mining and resource extraction, especially raw uranium, when we don't participate in that currently. And then also on the spent fuel processing side, we don't have a lot of effort there specifically focused out of our core businesses. Now, spent fuel processing and other fuel processing that occurs at the national labs, we do have multiple joint ventures and management and operating contracts where BWXT employees are there. But yet we try to stay focused on the designs and advanced technologies, the new designs. But each one of our designs is coupled with testing and coupled with the manufacturing development, right? So as a manufacturer, if we can't build it, we're not going to make it very far on the design. And having that interplay is something that we really pride ourselves on.
Now, the NRC has kind of the operating license, the construction license, but then also a manufacturing license for, I think, these microreactors. Are you guys looking at getting one of the manufacturing license, or just having a construction permit, or how are you guys thinking through that? It's okay if you don't know the answer. We didn't prep you for that one.
No, it's okay. It's a good question. I'll say a little bit about what our license is. So we have a Category 1 license, which allows us to handle large quantities of a variety of enrichments. So our license allows us to do that. The other part of construction that's important from an NRC standpoint is they do a very good job of coupling their requirements to ASME requirements. And so we've been working with ASME to get the credentials and qualifications required to be able to construct high temperature gas reactors and build those out. So right now, our primary program in advanced technologies is the PELE program, and that microreactor will be licensed through a DOE authorization basis. So the beauty of that is we can stay super focused with the Department of Energy, providing all the inputs required to get that authorization basis. And then the NRC and the DOE are working together to understand those inputs and understand how that could be used in the future to license through the NRC route. So I just see it as stepping stones right now, being focused on what's immediately in front of us, but then using that as a stepping stone to go commercial in the future is how the program has been set up. And I think it's been a big benefit for the government to have that broad view.
Gotcha. Yeah. So let's dive into PELE. This is an awesome project. I think it's a monumental step forward for the industry. Super exciting. I've been following it for years. I think there was a paper published in 2016 by the Army that was touting the need for a system like this that could be taken to the front lines and eliminate diesel supply chains? And the government put together a contract for it, and you guys eventually won it. So, but I'm curious on your description of the history and the background of the project, what the goals are, and where you guys see it going.
Yeah, absolutely. And I think it's an awesome project as well. I totally agree. And I feel fortunate to be part of BWXT and being able to site this reactor. So that's not something people have been able to say in a very long time. Citing a brand new reactor design, it's historically based on a lot of other reactor designs, but as an advanced nuclear microreactor in the size and mass restrictions that would be required by the Department of Defense just provides a whole new set of inputs into that reactor design. So being able to work through that over the last 2.5 years has been very rewarding. And then being awarded the contract mid-year last year has allowed my organization and really the industry to be able to pivot, not just from a design standpoint, but now we're getting closer and closer to delivery and testing of a new nuclear system. And so it's been extremely exciting. And I think the outcomes of having this system available are really important for tactical capability, especially when we are so heavily reliant on the supply chains that are required for diesel and other attributes for producing electricity abroad. So maybe not in the forward operating base standpoint would be the first use case, but having that capability in the U.S. government to deploy megawatts on demand would just be an enormous asset. And it kind of goes back to how nuclear became so prominent in the United States, having a deterrent capability and then also having a tactical capability to keep peace throughout the world is extremely important. So that kind of mission resonates very well with BWXT and my staff in advanced technologies.
Yeah, that makes a ton of sense. So talk to us about the distinction, and if there's any distinction with the NRC licensing process. You mentioned the DOE certification. Let's dive in a little bit more and try and understand that better.
Yeah, so they're very similar, right? And both regulatory bodies, the Department of Energy and the NRC, really just need to understand the entire safety case. And with the dimensions and the geometries and the nuclear physics that go into this reactor design, there's just a lot of input that's required for the DOE to do their job. And so what we have set up and through Idaho National Labs done a really good job of setting up all the input parameters that are required. We've been able to tie that to all of our activities and our design schedule. And then we're able to start working very smartly, finalizing all of the design inputs for the authorization basis, and then couple that to some of the procurements, long lead procurements that we have to make to be able to get those components in and start the assembly process. So as you can imagine, there's a lot of activities happening in parallel. And the DOE having an authorization basis process that's already been established to this design, especially through the collaborators that we have at Idaho National Lab, as starting to hit a stride. And from an NRC standpoint, they have very similar input requirements to go through the regulation and certification process. And so what they are looking at is how does that complement what they currently know? How do they need to alter or customize the NRC specific licensing process to what the DOE is doing? And then I think the outcome, like you mentioned at the beginning of the podcast, is an establishment of what new nuclear is going to look like in the future. So all of that put together is a lot of activities, a lot of work happening simultaneous, but it's been pretty well orchestrated. And I think once again, the government's done a really good job of making sure that it's orchestrated in the right way.
Yeah, that's incredible. I've managed a bunch of large projects before in my career, so I won't hold you to this, but what's your guys' current timeline for kind of the first prototype being completed or tested? I know, timelines can slip and there's delays all the time, but what's your current forecast?
Yeah, so we have 2 separate contracts within BWXT. They are both competitively awarded. The fuel will be delivered in 2024. The reactor system will be delivered late in the year. 2024 is the timeline, and then there's a fuel assembly that has to occur at Idaho, and then the test series starts in 2025. And then if you could think about it right now, Mark, it's the beginning of 23. A lot of the end users are becoming more and more interested in this product. So the type of testing schemes and how that's integrated into the end user is still being established. So I would say that the test probe will be heavily dictated on what the end use case or the immediate use case would be, and then what the customer is really looking for. So the obvious commissioning and shakedown and all that test engineering that I knew and loved when I was performing that for about a decade in my career is going to be important. But then when we take that unit through its paces and really understand the operational and performance capability, I think will be heavily dictated by the customer.
So who do you anticipate to be some of your first customers, or who's expressing interest in this so far?
Well, just based on our current customer Strategic Capabilities Office, I anticipate the armed services picking it up, right? So in that report that you named,
the military, right? They're engaged with the contract. Like, hey, can we have one of these things? We want to buy one.
That's right. That's right. And it was rewarding to be back and talk to the military folks. It brought me back to my early days in my career, just to understand what they're hyper focused on. What is it going to take to operate? How hard is it to set up? What are the maintenance requirements? What does training look like? All of those things that are really important. But there's a variety of customers within the government, and you saw in that report in 2016, I think a lot of that holds true. And then you start to extend that to disaster relief and off-grid applications and things like that. So I do see there being a big need, especially energy security being such a prominent topic now, and will continue to be a prominent topic in the government moving forward.
Are there any non-government customers that have expressed interest?
Yeah, so we have a variety of industrial customers that have asked us, right? So we have the contract to site one of these reactors. There are a lot of designs out there, there's a lot of designers out there, but BWXT and our ability to deliver nuclear systems, plus the fact that we have this contract with GO, has brought a lot of customers to us, and we've had a lot of meaningful conversations with them. So mostly industrial applications. A microreactor is really best used, especially as a high temperature gas. Microreactor is best used for industrial applications. Electricity prices are really high, thermal energy prices are really high, and also you need to have some robustness that would couple well with an industrial system. So we've been talking to a variety of customers, and we expect to continue that in advancement of kind of the offshoot after we finish the PELE program.
Awesome. Do you guys expect there to be kind of a ramp up period? I mean, getting to the first prototype's one thing, but then having an nth of a kind, and scaling up and being able to get these out the door. How are you guys forecasting that?
Yeah, we're looking at high throughput manufacturing of nuclear reactors, which I don't think anybody strung all those words together and made it real.
A lot of people have dreamed about it, but yeah.
That's right. And that's where you get the economy of scale. And that's where you can drive the costs down, and that's where you can propagate the technology in a very meaningful way. So we are looking at that. And we also have a commercial advanced reactor demonstration program. It's the reactor is called Banner. It's a different size. There's some design features that are different. It's based on the commercial marketplace, but focusing on what it's going to take to get to nth of a kind is extremely important, because that's the next question that all of our customers are going to ask. They're going to ask how it works. What is it going to take for me to operate it? And then the third and probably most important question is, how many can I get and how much do they cost? And being able to answer that responsibly just requires a lot of legwork. So we are focusing on that and what that ramp looks like over time. And we know we owe it to those customers to have a good feeling for what it's going to cost if they want to make a large order. And I think that behooves the whole industry to have that right the first time.
Absolutely. Makes sense. Are there any high-level technical details you can share? I mean, anything that would come from kind of a cut sheet or stuff that you find on your website?
Yeah, well, for the PELE reactor, it's really what Jeff Waxman, the program manager, has been talking about, the design features that are most important. So having 1 to 5 megawatts electricity on demand, being able to site the reactor rapidly, being able to shut the reactor down, have it effectively cooled down and transported within a week. Things of that nature is really important. And it's funny because classically nuclear trained people like myself and my staff don't really think in those terms. It's typically, how can you extract as much energy out of a given design, BWR design, to increase profitability for the utilities, which is very important for the ratepayer, important for the utilities and everything in between. But this is more of a tactical machine. So the requirements of being able to deploy quickly and then remove quickly and not have any remediation that's required in the site in which it was operated are all extremely important. So that's been a lot of the driving focus for my design team and ultimately with the operations team that we'll see in the government.
That makes sense. The transportation of spent nuclear fuels, certainly a problem. Are you guys thinking about addressing that? This reactor is kind of meant to be mobile, and transporting fuel or spent fuel or fuel that's been radioactive, it has its own set of hurdles.
Hmm. Yeah, I think so. So that's part of the scope, is understanding the end of life containment that would be required within the ISO container or Connex box. And then what are the design attributes of the reactor pressure vessel that will help that get through the licensing case for the NRC and other Department of Transportation licensing requirements. So we have been thinking about it. I think that's something that's just been running in parallel to us being hyper focused on finalizing all the design inputs, getting through the licensing basis, and ultimately
Right.
building a unit. But you're right. I mean, that is something that will have to be addressed, and it's something that has been addressed in a variety of commercial and government applications. We just have to be able to take the lessons learned from that and apply it directly to the SCO PELE
Yeah.
program.
Yeah, there's DOT approved containers that we can move these things around the country, but if it doesn't fit in that container, then you've got a problem, or you've got to figure out a different set of rules, right? So
That's right. Exactly.
So what are some of the other hurdles or challenges, roadblocks that might delay the project? I know it's a tough question to answer, especially publicly, but I mean, is there any risk to the project that you guys see right now?
Well, I would say any first of a kind project has risk. And if you think
absolutely.
about it, in every industry right now, there's risks in supply chains, there's risks in being able to deploy first units with the supply chain difficulties that have been stimulated by COVID. But I don't see any huge hurdles. It's just work and activities, and there's nothing standing in our way. The government did a really good job of being able to supply the input feedstock material for the fuel. We've been able to go through our design and have that design reviewed by the customer at a very frequent basis. So there are very few unknowns. It's just roll up your sleeves, get the work done type effort. And so as we go through that program, understanding the risks and communicating those risks is something that is very important in our program and evolution. But yeah, I don't see any huge hurdles, but only time will tell, and we'll continue to work the problem. And I feel very confident we'll be able to deploy this unit and have it operating in the very near future.
So do you think the system will be feasible to be licensed and sell to customers both in the US and out of the US?
I think so, from a commercial variant of this, right? So there's a tactical variant of this that the government will control. As a commercial variant of this, having power on demand in remote locations or high priced locations is always
super
gonna be
valuable.
Exactly.
It's awesome.
Exactly. And so it's a little bit of, if you build it, they will come type scenario. And I think that's why it's so important for SCO to be that pathfinder for new nuclear. And they've done a good job of just keeping their eye on the prize and understanding that being able to show that the technology works in a small mass and a small volume as compared to existing nuclear systems, that is a huge hurdle for us to overcome as an industry. So the commercial customers will come, and I think the commercial customers throughout the globe will come, and it'll help. It'll be a part of how we, the energy issues that we currently face right now as on Earth.
Yeah, and I'll admit ignorance. You said SCO a couple of times. I am not familiar with the acronym or the word.
Oh yeah, sorry. SCO is the Strategic Capabilities Office. That's our
There you
customer for Project PELE.
Gotcha.
Yes.
Gotcha. Yeah. Cool. Okay. But any other thoughts on PELE or any other things that you want to cover?
I think we covered everything. It's really just what we talked about. The development phase is concluding. We're getting into the build phase, and the prototype demonstration phase will happen next. And like you mentioned, it'll be a great win for nuclear writ large, and I'm just excited to be a part of it. I'm excited that BWXT could be in the lead for it, and really exciting to see how this stimulates the entire industry.
Awesome. Well, let's zoom out a little bit more and kind of focus on the broader energy industry. So how do you view the market for advanced nuclear changing in the coming years? Do you think it'll grow?
I do think it'll grow, and
So it's a softball for you, right? Like, yeah, Mark, I'm working to develop an advanced reactor. Of course, we think it's going to grow.
That's right. My organization's literally called Advanced Technologies, and so, but it is a good question because there's a spectrum of work that's
maybe the question is how does it grow and how fast?
I think it grows in two ways, maybe in three ways. So the first is what GE Hitachi is doing in Canada, right? So that commercial market is being really restarted in Canada through their SMR design. So that SMR being built in Canada is going to be a huge win for nuclear in the commercial sense.
Absolutely.
Right. And they did a very smart thing in the way they chose that program, because they have an existing technology that they're customizing for small modular reactors. So there's a lot of known knowns. And what they don't know, they're probably pretty familiar with. And so that gives a very high probability of success of that program. And then that's on the commercial side. We talked a lot about PELE and the microreactor side. So being able to start that part of the industry up and provide that tactical capability, and then have the commercial offshoots is going to be very important. And then you think about space, right? So a large fraction of my staff focus on space applications, both propulsion and power. So we have contracts from NASA, we have contracts for fission surface power and nuclear thermal propulsion. And so I see the space domain becoming extremely important, both from an industrial side and from a military Department of Defense side. So I think if you couple all three of those things, there's been an enormous wave of new activity in nuclear. And even though all three of those applications are different, we have a society of nuclear engineers and other engineers within the US that are becoming hyper-focused on each of those three activities. And I give all of them very high probability of success just based on the need. There's a strong desire, and that's really important.
Yeah. And you guys are certainly a front runner in advancing and changing that technology. So I commend you guys on that.
Thank you.
Taking a step forward, and this is, certainly we'll pontificate about this, but do you think nuclear will ever outcompete fossil fuels?
I'm not sure about outcompete it. It may be, when I think about fossil fuels, I think there's always going to be a need, right? There will always be a need in hydrocarbons in fossil fuels. One of the things that I think will be most interesting would be, how do we distribute energy in the future? Do we distribute energy like gas stations? And with electric vehicles, is there a new distribution of energy that will be required? I do believe that solar and wind and nuclear can work harmoniously together to be able to offset CO2 substantially in the future. I also think all three of those applications, especially nuclear, can make synthetic fossil fuels, which will help with carbon emissions and things of that nature. So I really don't even think about it as a competition. I know it's the easy answer, right? It's all about energy mix, and that's a bit of a buzzwordy answer, but but it is true. You can never replace immediately any of these technologies, but the market and the way that the integration of the market, especially with energy distribution and all of the different energy supplies that exist right now, how all of that gets matrixed in the future will be pretty interesting to me. But nuclear, U-235 energy density is a very, very strong case, right? So it wins in a lot of different applications. So
The
I like our
underlying
chances.
fundamentals of the physics and how much energy is encased in the raw material is very attractive.
That's right.
So
That's exactly right.
So in your perspective and your experience, I mean, you've got a big team working for you. I'm sure many of them come from the nuclear industry. Some perhaps don't. They come from other industries. What kind of opportunities do you think exist in the nuclear industry for individuals or even companies that are looking to pivot and add to this space and add to the work that's being done?
That's a great question. In staffing is always something that we're focusing on, much like many employers in the US and abroad. So there are huge opportunities in being part of a new engineering project. It is a nuclear project, which I think provides an additional desire for many folks, and it also provides a new entry into a new field for a lot of engineers. But from the spectrum of engineers that we hire, only maybe 25% of them are nuclear trained. We hire a lot of material scientists and other engineering disciplines. And so we've been attracting a lot of talent outside of the normal nuclear pipeline. And I think most of that staff has been extremely excited about what's happening in space, what's happening in microreactors. And it provides some robustness in my organization too, to get those ideas from different industries and be able to apply those ideas to some of the big engineering projects that we have within BWXT. So there are a lot of opportunities, and we're looking across every industry that understands high consequence design and high consequence manufacturing. A lot of that exists in medical, a lot of that exists aerospace, a lot of that exists in civil applications of engineering. So I think if coupling those resources and attracting that talent is been pretty rewarding for me just because of the feedback that we get from that staff when they join Advanced Technologies.
Yeah, I was going to ask what skill sets do you think are helpful, but you said high consequence industries. So I imagine people that have motivation for excellence and understand that the work that they do needs to be correct the first time. Am I thinking about that correctly?
Yeah, absolutely. The quality assurance aspects of it and just, the integrity that goes into engineering is very important. And when you apply that to something high consequence like nuclear, it becomes even more important.
Yeah, absolutely. Any other key skill sets that you can think of that would make folks successful in the space?
Well, I think systems engineering and project management, right? I mean, like you mentioned, you're familiar with managing big projects and having that ability to orchestrate across a variety of disciplines and meet customer requirements and work with our subs. We have two fantastic subcontractors on PELE and Northrop Grumman and Rolls-Royce Liberty Works. And so having that skill set too is also extremely important. Most of all of my project managers are engineers that by background and training, but being able to apply that engineering mindset into managing programs and things of that nature has become really important to us as well.
Absolutely. Figuring out how to motivate people and hold them accountable and yeah, hold contractors and subcontractors accountable, and not from like a iron stick and whipping people into shape, but rather motivating them to do excellent work. It's a continuous challenge, but some people excel at it.
It is, yeah, and there's that balance, right? Of when does engineering need to wane and when does procurements need to ramp up? And
Right.
so,
Yep.
having that understanding of engineering is the fundamental that's required, but then being able to orchestrate it, like you said, is a skill set all unto itself.
Absolutely. Cool, Joe, we're coming up on our time, so I want to ask you kind of our final question. What gives you hope? Leave us on a positive note about the future of energy and where you see all this going.
What gives me the most hope is the conversation that has been started over the last couple of years specific to energy, right? It has become a very meaningful and honest conversation. There was a lot of political conversation that I think has happened over the last several decades, but the conversation has become very honest on what does that energy mix need to look like, and how does nuclear play a part in that energy mix? And so that has allowed us in the industry, in the nuclear industry, to reemerge with some very, very interesting ideas. And so the fact that the universities are continuing to churn out really great talent, I've seen that from a dozen universities that I've interacted with over the last 5 years, plus that honest conversation in energy gives me a lot of hope. And being able to look at the spectrum of different applications of nuclear, I don't remember a time, at least not in my lifetime, where you had such a fast ramp in new nuclear technology for the government, for the commercial industry, and then also for space applications, all happening simultaneously. So that my hope is really in the opportunity that we have in front of us as part of the nuclear industry. And I see that every day in the conversations that I've had inside and outside of BWXT. And it really feels good to know that we're on a path to success.
I couldn't agree more. I think that's a fantastic note for us to end on. It's going to be a super exciting next decade. We'll look back and say 2020, 2022, 2023 was kind of the launching point for restarting this. So, Joe, thanks so much for your time. We really appreciate it.
Yeah, thank you, Mark.